All right, we are going to look at two more examples of how we can use completing the square. These two examples are a little bit trickier, but I wanted you to see that it is possible to use completing the square in pretty much any quadratic situation. So this one is tricky because it has a number in front of the x squared. So whenever a is not equal to 1, our first step needs to be to factor that out, whether or not b is divisible by this number. So I'm going to factor out a 2, and it's going to be kind of intimidating at first because that means that b is going to be 1/2. But I'm still going to put plus blank equals 6. If I want to put my plus blank over here, I can as well. All right, so I need to complete the square. And so I'm going to have 1/2, and I'm going to write it a little differently. I'm going to write it as divided by 2, quantity squared. But hopefully we know that if we divide by something, it's the same as multiplying by the reciprocal. So I'm going to get 1/2 times the reciprocal of 2, which is 1/2. Quantity squared. So this is going to give me 1/4 squared. And 1/4 squared will give me 1/16. So I know that that's not very pretty, and some of you are cringing and wondering why I'd make you do this, but just bear with me. Trust me, it's going to get better. So I'm not going to put 1/16 here though. I have a number on the other side, so I'm going to multiply what's on the outside of the parentheses by what I just completed the square with. So when I do 2 times 1/16, I would get 1 and 8 here, so that would just give me 1/8. Now, when I factor this, I'm going to get 2 times x plus 1/4. Remember, I'm just putting in whatever this number is before I square it, quantity squared. And then if I do 6 plus 1/8, I want to change this to be a common denominator, so 48/8. And right now I'm having a little flicker of hope that maybe this will not be the worst thing in the world, because when I do 48 plus 1, I get 49, and 49 is a perfect square. So before we square root anything, I am going to divide both sides by 2, or as we just saw, that can mean I'm going to multiply by 1/2 on both sides. And so over here, I get x plus 1/4 quantity squared, but over here, I get 49/16. And now I'm really excited because those are both perfect squares. So I am going to now, what color? I'll use green. I am going to square root and square root. This would give me x plus 1/4 equals 7/4. And because I can get a whole number, not a simplified radical, not a complex number with an I, I'm going to write it twice. X plus 1/4 equals 7/4, and x plus 1/4 equals -7/4. And what's even more beautiful now is that my denominators are the same. So when I subtract 1/4 to both sides, I'm going to do 7 minus 1, which gives me 6, and I get x equals 6/4, which simplifies to 3/2. Over here, when I subtract 1/4, I get -7 minus 1, which would give me -8. And so I'd get x equals -2. So my two answers are x equals -2 and 3/2. So even though I had to work with some not very pleasant fractions in there, I still ended up with an answer that really was not that bad. One more thing that we can do with completing the square is to change standard form into vertex form. So I know that we looked at this with like, oh, you find the vertex -b/2a and all that, but we are going to see what happens if we write it like this. So I'm going to start by, I'm going to bring this down here, actually. And I'm going to bring that +2 or that -2 over to the other side. So I'm going to have y minus 2 equals x squared minus 10x, and I'm going to put plus blank. So I'm going to have, when I complete the square, what am I going to get in that blank? 10 divided by 2, quantity squared, which would give me 5 squared, which is 25. But remember, I'm not just adding 25 there, I got to add 25 to the other side. So when I do 25 minus 2, I would get y minus 23 equals x minus 5 quantity squared. And this almost looks like vertex form. Vertex form, remember, was y equals a x minus h squared plus k. So the only thing I need to do is get y by itself. And so I'm going to plus 23 and move it back over here. And this would be my final answer. Oops. And as a little bonus, what would my vertex be here? My vertex would be 5, negative 23. So there you have it. That wasn't actually the question. The question was to put it into vertex form. Now you've got two different ways that you could convert from standard form into vertex form. Completing the square helps us do that. You've also seen that the value of a does not have to be 1 in order to convert or in order to solve a quadratic function. But yeah, I think that the completing the square method is actually really good, really useful. It's just different than anything that we've seen yet. And so it can be kind of intimidating. So let me know how you're feeling about this. Are you thinking that this is going to be a good thing, or is it kind of intimidating, overwhelming? What questions do you have that I can answer? Let me know and I will be happy to help.